Welcome back, friends. Previously, we were discussing about matrices, its concept of matrices, types of matrices, and different operations in matrices, under which we have almost completed addition as well as subtraction, and a case where multiplication of matrix with a scalar. Today, we will discuss the next operation, that is multiplication between two matrices. Multiplication of two matrices. Previously, we discussed about a case where multiplication of a matrix by a scalar. Under that method, we will multiply a common number with each element within a matrix. That is a simple case of multiplication. Here, the multiplication of two matrices is another operation that comes under operations of matrices. Under multiplication of matrices, two matrices are multiplied in such a manner that there are a number of steps that are peculiar only for this case of multiplication of two matrices. Today we will discuss in detail how to take the multiplication of two matrices. The matrices A and B, it's just a name given for two matrices, are said to be conformable for multiplication. The term conformable for multiplication means we can't always multiply any two matrices to each other. There is one common rule for multiplication of two matrices. Whenever two matrices are multiplied to each other, you need to make sure the number of columns of first matrix. Here in this case, first matrix is given A and second matrix is B. So make sure this is a common rule that has to be considered. The number of columns of first matrix must be equal to the number of rows of its second matrix. This is a common rule. Only if this rule is satisfied, you can compute a multiplication of two matrices. You have to remember this concept because sometimes you may come across a question where you may given two matrices and you are asked to compute whether you can multiply these two matrices or not. So before you directly go into computation, make sure whether the number of columns of the first matrix has to be equal to the number of rows of the second matrix. That is the first common rule that has to be considered before going into the multiplication part. Next one. The multiplication of two matrices is quite tricky. Once you understand the logic and the concept, it will be quite easy. Otherwise, it will be a headache for you guys. So now from now on, please be very cautious. Let us assume the first matrix, for time being it is given A. These are the elements of first matrix. It is in the order of 3 into 3 because it consists of 3 rows and 3 columns. Let it be first matrix. So instead of using numbers or numerics, we can use alphabet supported by its subscript depicting its position in the particular matrix. A11 means we all know A11 represents first element in the first row. A12 represents first row second item. A13 represents first row third item. Likewise, all other items represent here the alphabet or the variable followed by a superscript represent its position in the matrix. I hope you guys know what is the meaning of all this. We have discussed in detail all these parts at the beginning of this module. Okay, let it be first matrix and let this be the second matrix. So for this first matrix you are given A, for the second matrix B. For the convenient parts only we are using variables. So this is both the matrices are in the order 3 into 3. And As I have told at the beginning, you have to make sure the number of columns of the first matrix. Number of columns. Here there are 3 columns. First matrix has to be compared with the number of rows of the second matrix. Here it is 3 rows. So it will be equal. When this concept or common rule is satisfied, you can continue with the computation part. So next, how you are going to multiply it? For the time being, I am just showing an example of any 2 elements within this matrix. We will discuss in detail regarding how to multiply each element of matrices in the application part. So, first rule, you have to make sure the number of columns of the first matrix has to be equal to the number of rows of the second matrix. And after that, second rule is whenever you are multiplying the first matrix with the second matrix, make sure the first row, if you are beginning with the first row, when you are using the first row, you have to multiply the first row of the first matrix with all the columns of the second matrix. That is, first row has to be multiplied first with first column of the second matrix. Then the first row has to be multiplied with the second column of the second matrix, and again the first row has to be multiplied with the third column of the second matrix. Then first part is over. Second part is second row has to be multiplied with again with first column. The second row has to be multiplied again with second column. Likewise, you have to do multiply each row with all the columns of the second matrix. You may sometimes find it confusing. For the time being and for the sake only, I am just explaining it. I will discuss in detail the entire aspect. So, if you are multiplying the first matrix with the second matrix, as I have told earlier, row has to be multiplied with all the columns. So for the time being, I am just selecting any 2 elements. So this will be the product of the multiplication of 2 matrices. For the time being, I am just showing the multiplication part of this element, that is first element, and the last one, that is this one. I am just showing only how the multiplication part works. Okay, let's see how we are dealing with this first item. So for the time being, I am selecting A11. Sorry, it's not A11, A11. Remember, never say A11, it's A11. Okay. Whenever I am selecting an element of the first matrix, remember I have to go for the same item in the second matrix. It doesn't mean that you have to multiply A11 with B11. It is not working like that. It is just for the identification of row as well as column. That is, as I have told at the beginning, you have to multiply the row of the first matrix with the column of the second matrix. So for the identification, which row has to be multiplied with which column. For that purpose only, here we are identifying which element has to be selected. So A11 is the first matrix has to be compared with B11, so that the row of the first matrix. So A11 is in first row. So first row has to be multiplied with the first column of the second matrix. Remember, here I am just selecting only the first element. So first row has to be multiplied with the first column of the second matrix. So first item, the multiplication of the first row and second row will get this part. So A11 is multiplied with B11, so you will get A11 B11. That is within this rectangle, small rectangle. Plus, see, there is a plus sign. Plus, so first you did A11 into B11 plus, next A12 into B21. A12 into B21. See, like this. again plus next A13 into B31, you will get A13 B31. So this is the first part. By multiplying all these, you will get the value of the first element of the new matrix. We did the multiplication of these first row with the first column only to find the first element of the new matrix. Here there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 elements in new matrix. New matrix means the product of these two matrices. We have done this multiplication of these two items, that is A11 into B11 plus A12 into B21 plus A13 into B31. By adding these three items, you will get the first element or first item of the new matrix. Likewise, you need to find the remaining 8 items. The procedure is same. You have to, for the next item, you have to do like this. So that is a basic concept. In the problem or computation part, I will discuss in detail each item with an example. And today I am just discussing only the basic concept of multiplication. You need to understand the concept of the matrix, then only we can go with the application part. I hope some of you guys got an idea of the aspect of multiplication of two matrices, and some may not get a grasp regarding the topic. It's okay. We will discuss in detail in the application part. So that is the concept. For the time being, I will show another example. There are 9 items in first matrix. I just show only the first one. Let us discuss another one, A33. So when I select the A33 means it is in the third row of the first matrix. So I have to compare it with the same item and the same position in the second matrix. And next is the concept is that we mark these two items in order to find the particular row as well as column. A33 is in the last row of the first matrix and B33 in the last column of the second matrix. For that, for identification of that row and column only, we are selecting as A33 and B33. Once the row is identified, you need to multiply each item to each other. So similarly, first item A31. A31 is the first item in this row. So you have to multiply that with the first item in that column, that is B13. When you multiply A31 and B13, you will get A31 into B13. Again, plus, after multiplying first item, you have to put plus sign, plus A32 into B23. See, A32 into B23. Again, plus. After putting this plus sign, next item A33 into B33. See, A33 into B33. Similarly, same case. We just follow the same steps and aspect that has been discussed in the first item. All these steps and concept and computations are similar. We have to be very cautious regarding which row has to be compared with the column of the second matrix. And you may find it confusing that in the beginning I discussed that a row has to be multiplied with each column of the second matrix. Okay, that the concept is true. For the time being, I am just showing two items of this example. That's why I am not showing the multiplication of all the cases. I am just showing two items. See, the first item of the new matrix and the last item of the new matrix. That's why I am not showing computations of all cases. In the application part or in the problem case, we will discuss the entire aspect. I hope you understand the concept of multiplication of two matrices. So familiarize the cases, understand the concept, just go through all these explanation which we have did now. And if you have any issues, just contact me. Now let us discuss with an example. Then you will get a clear picture about the multiplication of two matrices. Example, it's an application case, so let's try an example. Then you will get a clear picture. Find the product of two matrices. Two matrices is given. First one is a 3 into 3 or 3 into 3 to 3 is to 3. It's the order of the matrix. So and the second one is 3 into 3. Is but the order of the matrix of two matrices is almost similar. And similarity of the matrix doesn't confirm that you can multiply that two matrices. The rule is the column of the first matrix has to be equal to the row of the second matrix. We have discussed that part in the previous slide. Just remember that. Okay, since the first rule is okay, then you can go on with the multiplication part. So, as I have told earlier, whenever you are selecting an item or an element of first matrix, that row in which the element you have selected, that row has to be multiplied with each column of the second matrix. You have to do the same process for the all items. So, if you follow that rule, you will get a computation like this. And if you solve all these values, you will get a new matrix. See, this is the product of these two matrices. This is how you have to multiply the two matrices, or it is a case where the multiplication of two matrices works. I hope you understand the concept. Just go through it. And I am very sure that you didn't understand anything, so I will discuss in detail how this matrix is computed. Okay, first one. As I have told earlier, whenever you are selecting a row, that row has to be multiplied with each columns. So first row is 1, 3, 2 of the first matrix. It has to be compared with the first column of the second matrix. So when you are multiplying, multiplication means 1 into 3. See, 1 into 3, 3 into 4, 3 into 4, 2 into 4, 2 into 4, only that much. You got the first element of the new matrix. So if you solve these numbers within this red rectangle, you will get 23. So you got first element. See, first element of the new matrix. Likewise, you need to find all the 8 remaining elements. Don't worry. We will discuss about that part. Next one. I hope you are following it. So you multiply first row with first column. Once you dealt with the first column, you have to multiply the first row with the second column. See, second column. So when you multiply this first row with the second column, you will get this one, this part. See, 1 into 1, 1 plus 3 into 2, 3 into 2 plus, once you multiply, after multiplication you need to put plus sign. 2 into minus 1, see, 2 into minus 1. If you solve these numbers within this rectangle, you will get this one. See, I hope you are getting the concept. Here first we multiply first row with the first column. First row with the first column, so the point where is this one. So when you multiply first row with the second column, you will get the second number. Likewise, if you multiply first row with the third column, you will get the third number. See, in the each cases the row was the first one. So see, here we got three numbers of the first row, and here in the second matrix we multiplied in each case each different columns. First, when you multiply first row with first column, you will get the first number of the first row. If you multiply first row with the second column, you will get the second number. Likewise, if you multiply first row with the last column or the third column, you will get, see, last item of the first row of the new matrix. See, so because in the first three steps our row was same. See, we computed three numbers. The three numbers was in the first row, and we selected three different columns for each case so as to find the three different numbers of the first row. I hope you are understanding the concept. Next, so once you have multiplied the row with all the columns, you can go for the next row. So, next one, second row. Second row. Second row means this one. See, like this one. First row was this one. So once you are going for the second row means this one. Okay. As I have suggested, the row has to be multiplied with all the columns of the second matrix. So second row has to be multiplied with first column, that is 0 into 3, 0 into 3, plus 2 into 4, 2 into 4, 1 into 4, 1 into 4. So you will get a computation like this. Once you solve this one, you will get this one, 12. Because we now multiplying the second row with each column. So when you multiply the second row with the first column, you will get this number. Likewise, if you multiply the second row with the second column, you will get the next number. See, second row with the second column, you will get the next number. Just like that's the same steps which we have discussed earlier. 0 into 1, 1, plus 2 into 2, 2 into 2, plus 1 into minus 1. By solving these numbers within this red rectangle, you will get 3. Next one, again second column, because we didn't finish with the columns of the second matrix. So second row of the first matrix has to be multiplied. We have multiplied with first column, second column, the last we are going to multiply the last column. So if you are multiplying these two lines, you will get a computation like this: 0 into 2 plus 2 into 3 plus 1 into 1, you will get 7. If you solve this computation, you will get 7. This is how you have to do the multiplication of the matrices. Remember the concept. And during the computation, you have to leave a space here, because this is the space that separates each element within the new matrix. So once you have multiplied any row with all the columns of the second matrix, you have to go for the next row of the first matrix. So now we have multiplied the second row with all the columns of the second matrix. So finally we are going for the third row of the first matrix, and this matrix this row has to be multiplied with all the columns of the second matrix. Why? We have to find these three numbers. That's why we are doing it. So first row has to be multiplied with not the first row. Third row or the last row of the first matrix has to be multiplied with first column of the second matrix. If you multiply these two, you will get 0 into 3 plus 5 into 4 plus 3 into 4. If you solve these numbers, you will get 32. Again, if you multiply the same row with the second column of the second matrix, you will get a computation like this, that is 0, 0 into 1 plus 5 into 2 plus 3 into minus 1. So if you solve this one, you will get, see, this one. And finally, you have one more column to deal with. last row of the first matrix and the last column of the second matrix. If you multiply these two, you will get 0 into 2 plus 5 into 3 plus 3 into 1. If you solve these numbers within this bracket, you will get 18. This is how you have to deal with the case of multiplication of two matrices. I hope you understand the basic concept, and through this example I hope everyone has understand the logic and what are the steps has to be considered and what are the rules and basic that has to be familiarized while dealing with the multiplication of matrices. I hope you understand the concept. So for the time being, please guys try to do this matrix as a homework. First of all, let's discuss the matrix. Here the two matrices are in two different orders. Here see both are square matrix. Here both are rectangle but in different style. Here it is in 2 into 3 because 2 row 3 column. Here it is in 3 rows 2 column. So in both cases the order is different. So first of all, make sure whether these two matrices can be multiplied. And the basic rule for checking whether two matrices can be multiplied is you have to check the columns of the first matrix has to be equal with the rows of the second matrix. Here there are 3 columns in first matrix. Here there are 3 rows in second matrix. So now it's equal. That means you can do the multiplication of these two matrices. That is the first rule you have to follow. The remaining rules are relating to the computation part. If you understand the concept, try to do this matrix as a homework. We will discuss the remaining part in the next session. That's all for today. Thank you.